everyone. So this session we have go to a new mathematics section. We discuss about things more related to statistics, and we start with the both concept of the mean and the variance, as well as the standard deviation. For mean and variance, don't use the common sense for that you are so mean. No, this is just a mean. This mean here is mean average. Okay, even not mean middle. Middle is in order, right? In the middle is order. Middle will be a new concept we call median. But here is mean. Mean is mean average. Variance, simply speaking, is the every item have the varies with the what? With the mean, right? It's variance. Anyway, that's my explanation. Of course, this is not the official one. So let's see the formula here. You see the formula here? The mean here, we use the expectation of the x, and we also call mu x. What's that expectation of x? X can be a group, can be a limited group or unlimited group of an item. Okay, the x1 until xn. And the mean is equals to corresponding x times their proportion in that group. So this is the average, am I right? I will give a, because now you see this one, it looks like very superficial. Let's give a short example. If x, this group, only have x1, x2, it's okay, right? Only have 3 units, and the proportion and the quantity. Okay, quality. Here's 100. Here's 200. Here's 400. Okay, but the portion here is 1/2. There's 1/4. There's 1/4. And they need to be 101, right? Why? Because they have to be. They including all the elements inside, including in this group A. So they have to be full, right? If not full, it's okay, and not you cannot get mean, right? You cannot only can get some part of mean, because they can have the I here. You can be I belongs to what? I belongs to. They can have an area, right? That's up to you. So what's this mu in this specific case? So equals to x1 times his portion, right? Times proportion of x equals to x1, am I right? Plus x2, same, plus x3, also p, right? The p, right? So what's the result? So x1 times p is 100 times 1/2 plus what? 200 times 1/4 plus what? 400 times 1/4. What's the result? 50, also 50, and this is 100, so 200. It seems like it's exactly in the middle, right? For this scenario, the median is equals to mu, right? Expect mean, right? But then it's normally not like this way. Okay. Then let's go to the variance. Variance is equal to what? Let's just exactly say that each unit, their difference with the mean and the square. So we will see the volume of their difference. That is a variance. And I just directly go down. The standard deviation is also measured as spread out number of this x. So standard deviation, we call that what? delta, right? Delta, right? And the delta is equals to square root of variance. Okay, so let's just follow this one. This variance, based on the example I give for x1, x2, x3, what this variance will be? Let's see, huh? So will be what? Look at here, will be this one, right? So xi, first xi will be what? Xi will be what? 100, right? x1 minus mu 200, am I right? And what? Am I right? Am I right? Am I right? Times what? 1/2. Am I right? And plus 1/4. What? 200 minus 200 plus what? 1/4. 400 minus 200, right? Then finally we got Vx. So simply speaking, if your Vx or standard deviation is more bigger, which means those items have a big variance, right? Have a big spread out compared with their mean, right? This is another formula of the Vx. Previously, Vx looks like this way. X minus mu, then square. Here they separate. Okay, so this formula is come from this formula. Okay, but they both are the right way. Definitely this way, this one will very simplify your what? Your what? Your calculation, right? For the future case, right? Okay. Okay. So another formula is variance C is constant. X equals to C squared. How come it's become a square? This one, let's change ourselves. Let's try to what? Prove it. Okay. So look at here. See Vx. So what's that will be? Sigma I. Am I right? Am I right? So this will be. Look at here. What is expectation? X minus mu square. Am I right? So it's what? Cx minus C mu. Of course, you mu also have to be times C, right? Then what? Square. Believe me, prove this one, you need to use this one. Okay, just let you know early. And then what happens? And of course, they have then what's this will be? Then this will be what? Let's separate this one. So equals to what? Cx square, right? Plus this will be minus, right? 2c square x mu. Am I right? And plus what? C square mu square. Am I right? And we all know that if just the plus and the minus in sigma, they can separate. Am I right? So this can be separated as a sigma c square x square, right? Then what? Minus what? Sigma, right? 2c uh, 2c square x mu, right? Then plus c square sigma c square mu square. And for the basic knowledge, if it is a sigma summation, if the constant can move out, right? And it's a sigma yeah, minus c square, right? 2c x mu. What's mu? What's mu? Mu is expectation of x. Am I right? Am I right? And then here is sigma of the c square mu square. They are both are constant, right? So there's no make sense of the sigma. So c square mu square. So look at here is equal to what? C square, we take the common factor, huh? Is sigma x square minus what? This is 2c square expectation square. Expectation square is what? Mu, right? 2c square mu square and then minus 1. So only left 1 mu square. And this is a c square vx. Why I cosine vx? I say I will use this one. Am I right? Expectation x square. Am I right? Expectation x square. Of course, I did not make it full. I can just write it as what? As a p, right? Right. X equals to xi, right? So, but anyway, just make it simple. So let's prove another one. Prove exy equals to ex times ey. How to prove that? Prove this one, we have to base on our base concept of what is exy. Exy is equal to what? Believe me, huh? This is very important. They have to be discrete, independent xy. If they have some kind of dependent each other, then this formula is not effective. So this can be xi, okay, or I. It's up to you. And then this will be j. Why I'm writing this later, you will know. Xi, yj. Now knows that. And then what? The p x equals to xi. Am I right? P y equals to yj, right? And this is exy, right? So let's just rewrite the. So this can be xi. Why we can rewrite it like this way? Because they are discrete. Or you cannot, because this is equals to the end, right? The end, right? Somehow it's like this way, the end. But since they are discrete, there's no any kind of dependent. You can move them separately. So this can be px equals to xi. We can move this one, j, and yj, and y equals to yj, right? So what will be looks like? This one will be exactly expectation of x, and this one will be exactly expectation of y. So that's why I prove this. Okay, so you can realize for this session, we have just have two examples, but we already know that for this is not a very simple conception, right, of the expectation value mu as well as the variance. We will go deep for next session, but okay. So thank you very much to join this session. Thank you and have a nice day. Bye bye.